Hello, my name is Jian Song. I'm making this video for question 1 in my homework 1 of probability and stochastic process. In this question, we need to prove it from both sides. First, let's prove that if A and B are independent, then probability A given B naught plus probability A naught given B equals 1. To prove this equation, we can rewrite the left side into two fractions. We all know that this conditional probability equals probability A times B naught over probability B naught. And this conditional probability equals probability A naught times B over probability B. We also know that probability A naught equals probability space minus A, which is 1 minus probability A. The same probability B naught equals 1 minus probability B. So we can rewrite these two fractions into this form: probability A times space minus B over probability space minus B plus probability space minus A times B over probability B. And then we can transform them into this probability A minus probability A times B over 1 minus probability B plus probability B minus probability A times B over probability B. Then we can combine these two fractions into one, and the numerator will be probability A times probability B minus probability B times probability A times B plus probability B minus probability A times B minus probability B to 2 plus probability B times probability A times B, and the denominator will be probability minus probability B to 2. We assume that A, B are independent. According to the definition, we can know probability A times B equals probability A times probability B. So the numerator of this fraction, we can see that these two parts are cancelled, and according to the independence, these two parts are cancelled as well. So the whole equation will be the combination of two conditional probability in the left side, and in the right side it's a fraction like this, and obviously it equals 1. So we approved that. So we have proved that if A, B are independent, then this equation is true. And second, if this equation is true, we have to prove that A and B are independent. As stated before, the combination of these two conditional probability can written into this form. In the numerator, probability A times probability B plus probability B minus probability A times B minus probability B to 2, and the denominator will be probability B minus probability B to 2. We have assumed that the combination of these two conditional probability equals 1. So in this fraction, these two parts has to be cancelled. Then this equation will be true, which means probability A times probability B equals probability A times B. And this is the independence definition. So we will prove that A, B are independent.